Okay, in this video, I'll be going through G3 Science, WA3, that was in 2024. The topics that are covered in this WA3 is actually moments and energy. Okay, let's start. So let's look at the MCQ first. Diagram shows the shape of a solid object with the center of gravity mark. So you also need to know what's the definition of center of gravity. And then they say which action makes the object more stable. So in order for something to be stable, right, the center of gravity is to be as low as possible. Okay, as low as possible. This is one way. Another way is that the base area, okay, so this is the base area, to be as large as possible. Okay, so if I were to look at option A, right, they say add an extra weight on its top surface, which means it will actually raise the center of gravity. So it's not what we want, because we want it to be more stable. Make the object from a less dense material, but the center of gravity will still be high up here, right? So it is not. Move it to a place where the gravitational field is larger. It is not as well. So turn it through 180 degrees. When I turn it through 180 degrees, the center of gravity will be this, right? So this is one of the way, make the CG as low as possible. So answer is D. Okay, question 2. The diagram shows 3 positions of the pedal of a bicycle which has a crank 0.18 meter long. Okay, so the crank is 0.18 meter long, something like that, where the cyclist exerts the same vertical downward force of 25 Newton, right? 25 Newton. Okay, what is the turning effect of the force exerted by the cyclist at position X, Y, and Z? So, to do this moment question, first of all, you need to identify where the pivot is. And the pivot will be over here, okay? So, if I were to look at X, the force actually passes through the pivot. So, the turning effect will be 0, right? Because there is no perpendicular distance. Okay, which will make D the correct answer. It will not be between 0 and 4.5 because basically there is no perpendicular distance. Now, moment formula is force times perpendicular distance. And in the case of X, the perpendicular distance is 0, right? Therefore, even though you exert a force, the moment will also be 0. But let's check Y. Actually, for Y, it's not so straightforward. Let's look at Z first. If we look at Z, this is the force. What I'm drawing is actually the line of action of the force, right? So this is actually the perpendicular distance. And since they say that the crank is 0.18 meters, therefore the moment in this case for Z, it is 25 Newton multiplied by 0.18. And I believe the answer will be 4.5 Newton meter. Okay. So if I were to look at Y now, I will again draw my line of action of the force. I hope you still remember how to draw line of action of the force. Basically, it's an imaginary line, right? You draw the line at the front and the back of the arrow. And this will actually help you to identify the perpendicular distance. Okay, and you will know that this is actually lesser. This perpendicular distance is actually lesser than 0.18 meter. Therefore, it will be between 0 and 4.5 Newton meter. Therefore, the answer is D. Okay, question 3. A helicopter rises vertically upwards. That means the height is increasing. At a constant speed, that means the V is constant. Okay, so recall gravitational potential energy. The formula is mgh, right? For kinetic energy, it is half mv squared. Okay, so if the h increases, that means my gravitational potential energy or energy in gravitational potential store will increase. So straight away, my answer will be B. But let us take a look at the energy in the kinetic store. Because the mass is constant, right? Helicopter is the same mass throughout the journey. The velocity or speed is constant. Therefore, the energy in kinetic store will be constant. So answer is B. Okay, a ball rolls down a frictionless ramp as shown. The ball has a mass of 2.5 kg. So I put it as M. At point X, the ball has 2.0 joules of energy in the kinetic store. So over here, because of it having a height, so it has energy in the gravitational potential store. It also has energy in the kinetic store according to the question, and it is 2.0 joules. So how much kinetic energy, how much kinetic energy store does the ball possess at point Y? Okay, so when it rolls down, the energy in EP will then be transferred to EK. But initially it already has 2.0 joules, right? So I need to find how much increase is the energy in the kinetic store. So I need to find what is the energy in the gravitational potential store. So I can use EP equals to mgh. Mass is 2.5, the g is 10 on Earth, multiplied by a height of 2 meters. So it will be 50 equals to 50 joules. So don't forget the initial energy in the kinetic store is 2, so we add them up together, it will be 50 joules. So answer is D. Question 5. A delivery man lifts boxes of equal weights onto a platform. Which quantity would not affect the total work done? Now, what is work done? Work done is actually force times distance moved in the direction of the force. So if he lifts the box up, the force exerted is upwards. And this is the distance that he lifts the box through. Okay, so far we have done 3 formulas. The first one for work, energy and power, the first one is EP equals to mgh. The second one is EK equals to half mv square. Then the next formula is work done equals to force times distance moved in the direction of the force. And number 4 is your power equals to energy times time. Okay, so far we have not seen any questions about this. Now, which quantity will not affect the total work done? He's carrying 4 boxes, right? So if the height of the platform above the ground, it will actually affect, right? If I ask him to move it up to even higher height, then he will need to use more energy and more work will be done. The number of boxes lifted, yes, right? Lift 1 box versus lifting 4 boxes. The time taken to lift the box, no, because if you look at the formula, it does not appear, time does not appear in the formula. So answer is C. The weight of the box, it actually affects the force that is required. Okay, so how about C, the time taken to lift the box? So C is actually linked to the power. So now if this delivery man takes 20 seconds to lift all 4 boxes versus another delivery man, he takes 100 seconds. Which delivery man actually has more power or is more powerful? Definitely is the one that is using a shorter amount of time. Okay, so as you can see from this formula. Okay, so question 5, answer is C. Okay, worker, now we come to section B. A worker carries a ladder on his shoulder. His shoulder acts as a pivot. So this is the pivot, right? So we will know that this is actually a moments question. So first of all, you need to identify where the pivot is. Okay, so we did that already. Okay, figure 6.1 shows that the ladder is horizontal. Okay, okay. So now the ladder is wider at one end than at the other end. That means this ladder is not uniform. Okay, that means if I were to measure the whole length of the ladder, I would not expect the center of gravity to be right smack in the middle, because there is more materials over here than at the front. So the weight of the ladder is 90 Newton, and because they tell us the center of gravity is here, I will actually have a 90 Newton force here. Okay, why do I need to write down all the forces there? Because step 2 is number of forces. Okay, so state what is meant by center of gravity. Please check your answer. I will upload later. I don't want to copy and paste and waste time. Now, center of gravity of the ladder is not halfway. State what this shows about the ladder. So it means that the ladder is not uniform. Okay. Now, center of gravity of the ladder is at a horizontal distance of 0.9 meters from the worker's shoulder. So this is the perpendicular distance for this 90 Newton, right? Because step 3 is you need to know the perpendicular distance of each force. Okay. They want us to calculate the moment of the weight of the ladder about the worker's shoulder. Simple. Moment equals to force times perpendicular distance, and the force is 90 Newton multiplied by 0.9. That means I'll get 81 Newton meter. Okay. Okay, part D, a bucket of weight 87 Newton. Okay, so this is 87 Newton. So now I know there are two forces. One is the 90 Newton, and it is 0.9 meters away from the pivot. The other one is 87 Newton. So I might as well write down the perpendicular distance, which is 1.3 meters. Okay, so actually there are how many forces? So far I've discovered two forces. Have I found out the perpendicular distance of each force? Yes. Okay, so let's see what else. The worker keeps the ladder horizontal by exerting a vertical downward force at point F. So where's point F? Point F is over here. He exerts a downward force. Okay, how much is the force? They didn't tell me, but they just call it F, and it is actually at a distance of 0.54 meters. So now can I change my step 2? There are actually 3 forces. Okay, so they are 90 Newton, which is the weight of the ladder, 87 Newton, which is the weight of the bucket, and F, which is what the worker is exerting. Have I found the perpendicular distance of each force? Yes. For 19 Newton, it is 0.9 meters. For 87 Newton, it is 1.3 meters. And for F, the downward force is actually at a distance of 0.54 meters. So with that, I can proceed to step 4, which is calculating the moment for each force. And moment is force times perpendicular distance. So when you see how I present the answer, this is the force part. Okay, this part is the perpendicular distance. Okay, and once you have found all the perpendicular distance, it becomes very simple. So I got my step 4. Moment for due to the 90 Newton is 81 Newton meter. For the 87 and 1.3, it is of a certain value. Okay, then for this, it is equals to 0.54 F Newton meter. Okay, now step 5 is to assign the direction. Okay, in class I've taught you all the pen trick. Okay, so basically for F, it is clockwise. For 90 Newton, it is also clockwise. The moment due to the 90 Newton force is clockwise. And for the bucket, the 87 Newton, it will create a anti-clockwise moment. Okay, and because this thing is horizontal, that means I can apply my principle of moment, which states that the sum of clockwise moment, which is 81, plus 0.54 F, is equal to the anti-clockwise moment, which is 87 multiplied by 1.3. Okay, so if you follow these 6 steps, you do it systematically, which is step 1, I repeat, finding the pivot. Where is the pivot? The question will tell you. Step 2, you have to determine how many forces are there. So as I read on, I discover that there are actually 3 forces. Then if I have 3 forces, I go to step 3, which is the most difficult. That means I need to know the perpendicular distance of each force. Then once I have all this information, I put it somewhere, something like this. It becomes very clear. Then I can go on to calculate the moments, which is force times perpendicular distance. Then I use the pen trick, okay, that I taught you all in class, to assign the direction, whether clockwise or anti-clockwise. And because the question says that it is horizontal, that means I can then apply principle of moment. So I add up all the clockwise moment versus the anti-clockwise moment. Then I do my math correctly. I'll get 59.4 Newton for my F. Okay. So let's go to question 7. Question 7, if I look at this, it will still be a moments question. Okay, but maybe they can add in energy, I don't know. So figure 7.1 shows a crane carrying a load. The arm of the crane can be raised or lowered, lengthened or shortened. Alright, so basically this can be lengthened or this can be shortened. So the center of gravity of the crane is over here. It's not the pivot, yeah, it's just where the weight seems to act in. Then I have this load. Now using the concept of moments, explain why lengthening and lowering the arm of the crane too much will cause the crane to topple. Okay, so if imagine I were to increase the length of the arm, right? I increase the length of the arm as well as lowering it. So you see, I lower this. So when I do that, I have a load here, right? And if this thing were to topple, right, the load will actually exert a clockwise moment about a pivot. Where's the pivot? It will be here, right? It will be here, because imagine, can you just try to visualize that this load, okay, if it's lowered and the whole arm is lengthened, it will then exert a clockwise moment because the force or the weight of the load is in this direction, vertically downwards, and then it will cause the crane to actually raise up. Okay, so this is the answer. Okay, when the arm of the crane is lengthened or lowered, the perpendicular distance of the line of action of the load. So this is a very important phrase, the perpendicular distance. Why? Because actually moment is about force times perpendicular distance. And I never say anything about changing the load, therefore the force remains constant. So then the moment will then rely on the perpendicular distance. So if you can see from my diagram, right, that I lengthen the arm and I lower it, the perpendicular distance will actually increase. Okay, so this will increase the clockwise moment, right, and therefore it will topple the crane. There is this possibility. Okay, so this is the answer. So take note of the keyword. Now figure 8.1, it shows a arrow just before it hits a target. The G is taken to be 10 Newton per kg. That's quite standard. The mass of the arrow is 35 grams. Red flag. This one should be changed to kg because this is an energy question. Okay. So how do I change it to kg? I need to use 35 divided by 1000. Okay. So it will be 0.035. Correct? Yeah. Okay, remember for energy, every formula requires the units to be SI units. So it's traveling at a speed of 20 meters per second. Yes, this is already in SI unit. So this is my V. Calculate the energy in a kinetic store. Simple. EK equals to half mv square equals to half times 0.035. Okay, so take note, everything needs to be in SI unit for energy. The V is 20. Don't forget to add in the square. The square is only for the V. So if I do this, my answer, I will get 7.0 joules. Okay, so simple. The arrow moves into the target and continues to move for 0.8 seconds before it comes to a complete stop. So calculate the power of the arrow. Okay, now power equals to energy over time. Okay, so they want us to calculate power. We have the energy from previous, so it is 7 joules over time, which is 0.8 seconds. Okay, so it is 8.75 watts. Now state the principle of conservation of energy. So remember to write down the correct way. So the previous syllabus says that it can be converted, right, from one form to another. No longer converted. Then you need to say from one store to another. Okay, and then you have the total energy in an isolated system is constant. Please go and check your notes. Now, using the principle of conservation of energy, explain why the arrow comes to a stop. Okay, so basically, the energy in the kinetic store of arrow, okay, that is the owner, is being transferred to internal store of the target. Okay, my handwriting is a bit atrocious. I will upload the answer. Okay, figure 9.1 shows the delivery man again lifting boxes of charcoal onto a platform. Each box has a weight of 100 newtons, so he actually needs to exert a force of 100 newton. And the platform is 1.1 meters. Calculate the work done. Now, simple. Work done equals to force times distance moved in the direction of the force. So it's 100 times 1.1. But we have 4 boxes, so we need to multiply by 4. So that will give me 440 joules. Okay, the charcoal is delivered to a restaurant where it's used for grilling Japanese eels as shown in figure 9.2. Describe the energy transfer by completing the following statement. When the charcoal is burned, the energy in the what store is transferred to the what store of the charcoal. Okay, so the energy in the chemical potential. Okay, store is transferred to the internal store. Okay, so internal store, it is linked to temperature or thermal. Okay, chemical potential store is energy that is not being released yet. Now, this energy is then transferred to the what store of the eel by what method or pathway, right? So the eel will actually also get energy transferred to the internal store by propagation of wave. Okay, so because it is not in direct contact, so we will need the infrared waves to reach the eel. Okay, so this is the solution for this WA.